Good morning, sir. This is Nitin from second CSC. The allotted topic is paging. The outline of this presentation is paging. What is paging? Paging table, plan selection look aside buffer, handling page faults, demand page and its advantages, swapping it and its role in paging, and the last the conclusion. First, the paging, revolutionizing memory management in operating system. Dive into the world of paging, a pivotal technique in an operating system that transforms how memory is managed. Paging is not just a method, it's a sophisticated strategy that enables process to access memory in a way that's both efficient and secure. This presentation will unpack the core principles of paging, its mechanism and its critical role in optimizing memory usage. We will explore how paging overcomes the limitations of traditional memory management, providing a more flexible and robust environment for application. Next, the what is paging? A deep dive. A paging is a memory management scheme that allows a process logical address space to be non-contiguous. Physical memory is divided into fixed size blocks called frames, and logical memory is divided into blocks of same size called pages. A page table used to translate logical to physical address. This allows process to be allocated physical memory wherever it's available without requiring contiguous block. This concept key benefits: efficient memory use, reduce external fragmentation, enables virtual memory, and the core concept contains pages and frame, page tables, and address translation. By using paging, operating system can improve memory utilization and support larger virtual address spaces than the available physical memory. And the next slide is about the page table, the memory map. Page table serves as the defense in the paging system, mapping virtual address to physical address. Each process has its own page table, which the operating system manages. This table contains entries the corresponding to each virtual page of the process, indicating the physical frame where that page is stored. This consists structure, functions, and manage structures. Entries include the frame number and control bits, valid, read-only, etc. And the function contains translate virtual address to physical address during memory access. And the third, management, maintained by the OS, crucial for memory protection and isolation. The page table allows the OS to control how much process access memory, ensuring that process cannot interface with each other's memory space. And the next slide is about the translation look aside buffer. Accessing the page table for every memory access would be slow. To speed things up, a translation look aside buffer is used. The TLB is a cache that stores recent virtual to physical address translation. When a virtual address is accessed, the TLB is checked first if the translation is present. This contains speed, cache, and efficiency. Speed is accelerate memory access, and the cache contains stores recent translation, and the efficiency improves overall system performance. If a translation is not the TLB, the page table must be accessed, which is slower. However, the translation is added to the TLB for further use. And the next slide is about handling pages faults. A page fault occurs when a process tries to access virtual address that is not currently mapped to a physical frame. This might happen if the page has been swapped out. The disk of the process is trying to access the invalid address. When a page fault occurs, the operating system must be handle it. This contains page fault, process access invalid page, and the next OS intervention. OS locates page disk, and the third, page replacement. Page is swapped into memory, and the last, the resume. Process continuous execution. The OS locates the page on disk, finds free frame, and loads the page into memory. The page table is updated, and the process resumes execution. And the next about demand paging and its advantages. Demand paging is a technique where pages are only loaded into memory when they are needed. This means that a process does not need all its pages in memory to start execution. Pages are loaded only when page fault occurs. The first, reduce startup. Process start faster, and the second, less memory required. Efficiency, overall system performance improves. This reduces the amount of memory required for a process, speeds up process startup, and improves overall system performance. However, it also increases the number of page faults. And the last, swapping and its role in paging. Swapping is a technique used to improve pages from memory to disk to free up physical memory. When memory is scarce, the operating system can swap and pages that are not currently being used to make room for other process. Swapping is often used in conjugate with paging. This consists 50% memory freed. By this, 10x speed impact and increased by 2 levels. When a swapped one page is needed again, it must be swapped into memory, which can be slow. And the last, conclusion. Paging is a powerful technique for managing memory in operating system. It allows efficient memory allocation, reduced external fragmentation, and enables virtual memory. By using page table, TLB's demand paging and swapping, operating system can optimize memory management, improves overall system. Thank you.